be able to do these river problems for two reasons. One is if you took physics, this probably seemed like unbelievably hard. But if we think of this rate plus rate equals rate, you can solve anything. You can solve anything. And here we go. Carl decides to explore and meander the river. The location of several recent Sasquatch sightings, of course Sasquatch. He canoes downstream at 5, which is 5 miles, and where he thinks there's a Sasquatch nest. Finding nothing, he turns around, retraces his route, and comes back to camp 3 hours after he left. If Carl canoes at a rate of 6 miles per hour in still water, now that's not in still water, Minnesota. Still water means no current. Would you write that? No current? That's what still water means. How fast was the river flowing on that day? Or in other words, what is the rate of the current? Well, now when I look at this, is the rate of Carl paddling plus the rate of the current, that's not a constant rate, is it? That's not going to work out. If he's paddling along at, 6 miles an hour and he's going against the current, he's going with the current, they'll be different. I don't think this is the formula that we want. I think what we want to look at is the time going downstream, excuse me, plus the time going upstream is going to be equal to the time total. And this is why this is just a little different. Would you erase that rate part, because rate doesn't work here. We're looking for the rate of the current. Time is what adds up. Time over, going downstream. Time back will be the time back, time down, time up will be equal to the total time. By the way, what is the total time? I think we know it. Yeah, the total time was 3 hours. That's good. Now, when we looked at rate, going back here, rate was equal to the amount over the time. When we're looking at speed, we're looking at distance over time, right? Do you agree with that? So would time be equal to distance over what? Speed or rate. So I'm going to have you hold on to this. This is good stuff. This is what I want to save. And I'm going to change this word for speed. We're just going to call this the rate. All right, so for cleaning out llama pens or digging holes, we look at rate plus rate equals rate of both. But when we're going a distance one way and coming back another, we're looking at total time. We're going to add up the times. Like that. Time is distance over rate. So if time is distance over rate, the time down is how far downstream did they go? What's the distance in miles in this problem? It says it. 5 miles. Yeah. Thank you. So it's 5 miles downstream. So going downstream, it's 5 miles. Now the rate is tricky. He can travel 6 miles per hour. But when he's going downstream, what's added to that rate? The current. Yep. So I'm just going to call this C for the rate of the current. Are you okay with that? Turn to your neighbor and see if they can help you figure out what the fraction is for going upstream. So when it went downstream, I'm going 6 miles per hour plus the current. You figure out what this ratio is going to be. 15 seconds. Andy, tell me what you get for the fraction here. How far did they go?
5 miles.
Perfect. And then what will the rate if they have to go against the current?
6 miles per hour minus.
Yeah, 6 minus C. Nice. There it is. And now what will we be able to solve for? 5 over 6 plus C plus 5 over 6 minus C equals 3. What will we be able to solve for now? C, and that's the rate of the current. Okay, and let's do that. Let's do that by multiplying by 6 minus C, 6 plus C, and unfortunately here we're going to have to do both. 6 minus C, 6 plus C. 6 minus C, 6 plus C. 5 times 6 is 30 minus 5C. 5 times 6 is 30 plus 5C equals 3. Let's see, 6 times 6 is 36. Minus 6C plus 6C is 0. So it'll be minus C squared times 3. Anything cancel out on the, oh, and all of these denominators, you can do a 6 minus C times 6 minus plus C. 6 minus C times 6 plus C. But if you multiply both sides by 6 minus C, 6 plus C, can you see how these are, you can ignore those? Did I go too fast? So then, Chris, what happens to the 5 C's here? Those are out of there. So you get 30 and 30 is 60. And that is going to be equal to 3 times 36, which is going to be 18. 108 minus 3C squared. So if I subtract 60, I'm going to get 48. Move the 3C squared here. You're going to get C squared equal 48. And C is just going to be the square root of 48. And that is miles per hour, I think. What's that, a little less? Did I do something wrong? Yeah. Oh, I forgot to divide by 3. There we go. Thank you. So this is going to be C squared is equal to 16. There you go. So C is going to be what? 4. Yeah. Or negative 4. So for the current, could the speed be negative? Well, if it was going backwards. So we'll just say the rate of the current is 4 miles per hour. Kind of a nice number. Turns out great. So what they're saying is 5 over 6 plus 4 plus 5 over 6 minus 4, which is 2, should be equal to 3. And if I put 5, what's 25 plus 5? 30. 30 over 10, is that 3? So it works. Congratulations. That is the current problem. And you're going to do a current problem right now using Homer Simpson to help you out. 21 and 22. Set them up. Time is equal to time plus time. And then see if you can figure out what the speed of Carl is. And then 22 is a speed problem as well.